in style. My name is Brian Benz. I'm a cloud developer advocate at Microsoft, and with me is...
James Faulkner. I run product marketing for Red Hat Runtimes.
All right, so we got a very compact session here. We're going to talk today about MicroProfile. We're going to cover a little bit about Thorntail, which is an implementation of MicroProfile, and then we're going to talk about Quarkus, which actually has an implementation of MicroProfile inside, and OpenShift as well, and a few other resources that we'll share with you at the end. And we have a ton of demos too. So real quick, what is Eclipse MicroProfile? It's an Eclipse project. Microprofile.io is the website you can go to. It's a community specification. It's not a standard. It's just a few vendors, and hopefully a growing number of vendors have got together and agreed upon some standards for sharing microservices. And if you want more info on that, you can go to microprofile.io. Here's some of the members of the community, the ones, lots of names you probably recognize here. These are people who participate in the Eclipse MicroProfile project. And we also have several implementations. I mentioned Thorntail before. We also have several other implementations based on different vendors' products and services. And today we're going to talk about Red Hat's implementation, as I mentioned, which was Thorntail. Okay, so what is Thorntail? It's just a way to basically leverage Java Enterprise Edition expertise in an open standard and focus on microservices. It's built for containers. It doesn't necessarily have to be containers you run it in, though. But if you do put it in containers, it's nice and lightweight, which is great for the horizontal world of scaling for container-based applications. You can have an Uber jar and a war. We're going to show you demos with jars today, and it implements MicroProfile 3, which is the latest version of MicroProfile that came out in June 2019. All right, so let's get into some demos. All right, so here's actually just my local command prompt, and it's a Maven application when you're working with Thorntail. So I just use the command Maven clean Thorntail run, and it's actually going to build an application for me that I've already specified in my POM. We've written a little bit of code for it too, and you'll see it running. All right, and when you get the message down here, Thorntail is ready, the application is actually ready for use. This application itself actually is an implementation of something you may have seen before, and let's have a look at it. All right, so here's the application, and the application itself is Minesweepers, this little game you can play, and basically when you play around, it's calling a microservice to store data on the back end. In this case, it's an H2 database that just stores data. And yeah, so it's just a simple, playful little microservice implemented with MicroProfile. This is running on my local machine on localhost. So let's examine how you would actually take this, containerize it, which is what you should do if you're working with microservices in general, and then deploy this to the cloud. In this case, I'm going to deploy this to Microsoft Azure. And this is, what you're looking at now is the Azure portal. And I've created this thing called a resource group, which is how you have to organize everything in Azure. And this resource group is empty. And what we're going to do is we're actually going to create a container. We're going to take that container and put it in a container registry. And then we're actually going to deploy that from the registry out to a container managing service based on Kubernetes. And I'll explain what all that is as we go along. So the first thing we want to do is we want to set up some environment variables that we're going to use as part of the process here today. So I'm actually using Visual Studio Code. It's an open source text editor you can get. You can just search Visual Studio Code and download it. It's free and open source, as I mentioned. So I'm going to use bash down here in this bottom window to actually activate all these environment variables that I'm using. I already created this group here. So the next thing I need to do is I need to create my Azure Container Registry. Whenever you work with containers, you need a place to put them before you deploy them anywhere else, and that's a container registry. Docker Hub is the most famous registry out there. I'm using the Azure CLI to do this, so I just say AZ ACR create, and I use the resource group I defined before. I give it a new name and a couple of other parameters that we need to pass. And when the registry is created, I get back some JSON down here, as you can see here. The next thing we want to do is we actually want to take our application, we want to build a container out of it, and then we want to deploy that out to the cloud, and to the container registry in the cloud. So let's do that now. We fire up, in this case we do an ACR build. So Azure Container Registry, ACR, has this cool thing where you can actually package up a set of files in your code and send it out to Container Registry, and the Container Registry will actually create an environment either in Linux or Windows that will actually build your container. And if that container build is successful, it'll actually store it in your container registry ready to be deployed. So right now what it's doing is it's actually creating a little tarball down here, and when that tarball is done, it's going to pile it up, it's going to put it into ACR for me. Once that tarball is up on the container registry, it actually creates the environment for me, and then what it does is it starts it logs into the registry, it checks for some dependencies. The next thing it's going to do is it's actually going to download a number of dependencies that are part of the Docker file that we use for this. So let's actually look at the Docker file. Here it is here. It's a two-stage Docker file. Basically what we're doing is we're using the Maven build for Java, JDK 8, which is actually out on Docker Hub. We're pulling that in to do the build. And then we use a lighter version of the JDK called Alpine, OpenJDK 8, to actually package with the deployment. That way we have full features when we're actually doing the build, and we have a lighter set of features when we're doing the runtime, because we don't need all those features in the build in our runtime. So it's actually getting a number of things here from the Maven. We have a pom.xml, which actually refers to a number of implementation details as part of the application. One of the nice things about Thorntail is everything's in XML. For example, if you want to create a dependency like Jaeger for open tracing, which James will cover a little bit later, you can use create a dependency IO Thorntail, and it will automatically be imported into your environment where you actually build the application for you. And there's a bunch of these here. A lot of them are the base parts of MicroProfile / Thorntail that you need to run, and more details on that at microprofile.io. But basically right now what it's doing is it's actually building the Docker file. It downloaded all the Maven files first, and now it's building the Docker file. And as you can see now, it's a successful build, and it's actually pushing it to the repository. So now it's in the repository, ready to go. Next thing we need to do is we actually want to get that container registry password. It's a brand new container registry, so we need to get that to use with our application. So we actually put it into an environment variable that we can use later. So now we have an application. We pulled a bunch of stuff based on the POM into the application. We built it. It was successful. We took a container image. We pushed it to the container registry. Now it's ready to deploy somewhere. So the first thing we want to do when we want to deploy somewhere is we send instructions to a deployment. And in this case, you use YAML. If you're going to Kubernetes, if you're going to any container-based application in general, you'll be wanting to use a YAML file that actually describes the deployment and what that deployment should include. In this case, we're using a file called deploy ACI YAML, and because we just created a whole bunch of stuff, we need to create some steps here to actually create the file. So the first thing we do, we make a copy of a template file that I have, and then I run some sed commands, and these sed commands will basically make some changes to the file based on the environment that we just created and the image we just created, and then we can cat it, or we can actually look at it over here as well. If we look at the actual deploy ACI YAML file, it's actually a fairly simple one. So it is using our local image. This is the ACR that we just created. This is the actual URL for that, and this is the image it's going to use. And it's doing some stuff with Jaeger as well, which we'll cover a bit later. And then basically it's just going to deploy that out to a container In this case, we're using something called Azure Container Instances, and it's just think of it like a big shared Kubernetes cluster that you can grab a pod with and run something on. So that's what I use for testing. It's really easy and quick to do. And I just built this ACI based on a template and plugged in the values that I needed to actually deploy out. And as you can see here, that's the password that we created in the environment variables for this particular implementation. So to actually deploy this, what we use is another Azure CLI command. It says AZ container create. And the AZ container create is going to use the resource group that we defined earlier. It's going to use a random string for the name, and it's going to use that YAML file that I just created, the file deploy ACI YAML, to pass some instructions to the container. As you can see down here, it's running right now. It's actually deploying that out. Now once that's done, I get some JSON back here to tell me what happened. The next thing we need to do is we actually need to get the URL and some other details of this, and we're going to use a JQ to do that. And just run these couple of commands here that'll go out and get our information. The next one is actually key because it gets the IP address of the container instance that we just created. Azure Container Instance will just have an automatic service. So normally if you're working with Kubernetes or something, you have to create the pods and then you create a service on the front end. This one has a service on the front end already, and it'll actually create that for us. Then we just curl the actual URL, and once that's done, I can just echo it, and it just tells me what it is right down here, and I can click there, open the link, and automatically we've got the game. So there we go. We just took that application from my local machine, we packaged it up with a Docker file, we deployed it to a container instance, which is like a big Kubernetes pod, and now we have a working game out on a container on the cloud. And this is actually even a little bit faster than my local machine, although there we go. And you can play it and do whatever you want with it. So kind of a cool little instance of working with MicroProfile and the Thorntail implementation, which is from Red Hat, and deploying it out to the cloud. So that's just a really simple demo showing you how you can run it locally. You don't need a container to use the base image, and then how you package it up to container, put it in the cloud. And James is going to show us some even cooler stuff of how you actually work with this on Azure using OpenShift and Quarkus. So over to you, James.
Okay, thanks, Brian. So what Brian showed is our simple application running on Azure containers, but the application doesn't do much. In fact, it's using an in-memory database, and there's really no traceability or observability or any of the things developers may care about in the application currently. So what we want to do is take this application and integrate it with more of the Azure services available to it through Azure and through the Open Service Broker running on the OpenShift container platform. So through OpenShift and the Open Service Broker, you can access services like SQL databases or Azure Functions or even Azure Machine Learning through a standardized interface. So in OpenShift, there is the concept of a service catalog that allows you to get access to these. And the service catalog is a dynamic catalog that shows you different services available based on the different service brokers that happen to be installed, such as the Ansible Service Broker or the Open Azure Service Broker, which is what we have installed here. So the demo, what we're going to do is show you more from the developer's perspective what it looks like to use MicroProfile APIs to build this application to integrate it with Azure services running on OpenShift on Azure. So we'll be using a new technology that Red Hat has championed called Quarkus. So what Quarkus does is essentially bring Java back into the space where it was formerly not really a good fit. So if we think of a traditional Java application stack built for monoliths and for microservices. It's typically a single application, like a runnable executable jar file. They may last for days. In the monolith case, they may take hundreds of megabytes of RAM, and they take seconds to start up. So there's the layers that in this application are the application business logic, the frameworks it uses, the application server or bits of an application server in the Thorntail case, and then you have the JVM. So what Quarkus does is take a lot of the dynamic behavior of applications that typically happen at runtime, like class path scanning or annotation processing, and move all of that to build time. So we can achieve extremely high, extremely low startup speed and extremely efficient memory usage. You can also then go even further and remove the JVM and run it as a native executable, which is what we're going to do. So let's take a look at the demo. So what we have is a basic Java application. This is the source code to the Minesweeper app that Brian showed. And what we're going to do is add a couple of extensions. So this is a basic Quarkus application you can build from quarkus.io. We're going to go ahead and add the MicroProfile extensions. This simply adds entries into your pom.xml, just like in Thorntail, and you can see a number of new dependencies have been added. So now once we have that, we can do interesting developer things for building microservices with MicroProfile applications. Like, for example, if I wanted to add, say, countable metrics, so I can expose metrics for my application and observe them over time, I can do that. So for example, if I wanted to add a timer for one of my methods in my database access, I can add a timed method here, and I can give it a name. We'll call it, we'll just give it the same name as the function, and we'll give it a display or a description, how long it takes, and a units to report the units in a particular unit. So we'll use milliseconds here. So that's a very simple timer. I got a typo here. Okay, so I've got my application built. I've added all my APIs. I've got a health check automatically through the MicroProfile extension in Quarkus. So now I'm ready to build. So let's go ahead and build it. So I'm going to run this in developer mode, live coding mode, in fact, so we can make changes on the fly and see what's going on here. So my application now gets up and running. It starts up very quickly, started up in about 1.8 seconds. And I'll open a new terminal, and we'll just curl it to make sure it's running. We'll look at the health endpoint. So I have a health endpoint. I've actually added a database check in my health endpoint. We also have metrics out of the box. So if you just go to the metrics endpoint or metrics application, you can see all the application metrics that my application is going to generate. So once we deploy this, we'll see this in action. Okay, so one other interesting thing that Quarkus brings to the table with MicroProfile is the ability to deploy and create native binaries. So I have my application running as a executable jar currently. We'll go ahead and stop that, and we'll start the native binary version of this application, which you'll see starts up even faster. Started up in about 58 milliseconds. So that's pretty good speed. It is continuing to work. So you can see the application up and running here locally again. So that's all well and good, and as I exercise the application, then we'll see those metrics start being reported, and we'll show you where those go. Yeah, so this endpoint, the metrics endpoint, you can see now I'm starting to get data on the metrics endpoint. So that's automatically generated through the MicroProfile extension for MicroProfile metrics within Quarkus. Okay, so now that we've built our app as a native binary, let's deploy to OpenShift and hook it up to our Azure services. So to deploy the application to OpenShift, I'll use the OpenShift command line utility called OC, a relatively simple command. So you can see the application now begins to deploy, but when it starts to deploy, it's going to have a problem. And the problem is that the application is expecting to talk to the Azure services, but we have not yet bound our service instance to the application itself. So typically what you'll do is you'll create a service instance through the service catalog, which you can see on the add option, where you can see a list of all of the different services on Azure that you're able to bind applications to. Once you do that, then those services are available, and then you can bind them. So let's go ahead and bind our application to that service. So we'll go ahead and find the secret that has our credentials for the bound Azure service, the Cosmos database service. So it's right here. So this is the secret. You can see the data. You can hit the reveal values button to see the values that the application will need to connect to Cosmos database. So go ahead and add that secret to our workload. So I'll just select the workload here. I'll give it a prefix so that we can recognize it and use it in our application. I'll go ahead and click Save. And now I'll go back to the topology view, and you'll see the application now starts to redeploy and is able to connect to Cosmos database. Okay, so the application is successfully deployed and linked now to our Azure services. So we'll go ahead and open the game. You can see this is the same game that Brian was showing earlier. I'll just go ahead and play it a few times and trigger not only our metrics but also our health endpoints and a few other things in the application that we'll show you. So played the game a couple times, caused a number of services to be invoked. So now what we can do is through MicroProfile and the things that we added as developers, we can now do things like find traces using Jaeger. We can do open tracing, which allows us to debug our application a little bit easier. So you can see the traces that were generated as part of the playing the game. You can also see those metrics that we defined earlier. So if I am in Prometheus, which is an open source metrics gathering tool, and I type in Microsweeper here, you can see all of those metrics that are generated as part of the application now show up in Prometheus. And if I click execute, I can get the values of these metrics. I can also then take it a step further and build on top of that through Grafana, another open source monitoring tool, and I can build dashboards. So for example, I built a Quarkus Microsweeper dashboard earlier, and you can see some of the metrics starting to come through from exercising the application. So very easy way for developers to add a lot of microservice functionality to their applications using MicroProfile APIs and implementations of those APIs that you can find both in Thorntail and in Quarkus. So that's it for the demo. So we'll wrap up. Just a few other pieces of resources for you. MicroProfile is an open community, and it's always looking for additional participants and people who can contribute something back. So there's a number of different ways you can do that. There are Google Groups. There are projects on microprofile.io. There's also a number of different meetings that take place that you can participate in. A YouTube channel with a number of good videos, and we also have Hangouts rooms that you can participate in with the rest of the community. So this demo today runs on Azure Red Hat OpenShift, which is a jointly engineered and managed and supported offering by both Red Hat and Microsoft. So if you're looking to build MicroProfile applications and connect them to the hundreds of available Azure services, like what you saw in today's demos, check out the link at the bottom to learn more. So just a few more links for MicroProfile. There's a link to a white paper that was just released this year, a new ebook, also on start.microprofile.io, an easy way to generate new projects, an events calendar.